Welcome student. So we come back again with our new video that can solve all your numericals problem related to the Coulomb's law. You know that the last video, in last video I discussed about the Coulomb's law, the different part of this, okay, and the SI unit, dimension, all these things. Today we just recapitulate these parts. After that we come back to the problem solutions methods. That is the in NCERT book that you know that huge number of problems are present in the exercise. So it is very much difficult for everyone. What way you can solve it, what way we can calculate at the exam time, because you know that during the exam time it is not easy to solve, to calculate all these values. So maximum students try to ignore this. This is the main things, okay. So when we ignore this, that is number deducted. So this is the main goal of yours. What way you can get your highest marks and you can solve all these problems very easily, okay. So before of this we just recapitulate the part, that is the Coulomb's law, then we move to our video, okay. Then see, so first one, the Coulomb's law. Coulomb's law, here we know that this is two charge body. This one is plus Q. Last day we discussed about that in my last video. That is, this one is Q1, this one is Q2. Okay, this one is separated by some D. This one if be positive, this one is also positive. So this one, what is the force between them? Obviously repulsive. If positive, this one is negative, then attractive in nature. So what is the force? That is F. So F equals to Q1 Q2 by D square. Okay, and obviously this is proportional. And when we represent proportional to equal, we needed a constant. This constant represented by K. So last day we discussed about these things. So this K is a proportionality constant and it is depend on the mainly two things, that is the unit and the medium. Okay. For SI unit, if I consider, the value of K is equals to 1 by 4 pi epsilon 0. Okay. So and its value is 9 into 10 to the power 9. You remember these things. 9 into 10 to the power 9, the SI unit's value. Okay, so if I putting this value over there, that is 9 into 10 to the power 9 into Q1 Q2 by D square. If you know more about it, obviously you watch my previous video related to the Coulomb's law. Okay, so now we just want to solve the first problems related to the ncert exercise. Okay, let's see the first numerical problem in exercise 1, that is the chapter electric charges and field. Chapter 1, the first question is, what is the force between two small charge sphere having charges of 2 into 10 to the power minus 7 coulomb and 3 into 10 to the power minus 7 coulomb placed 30 centimeter apart in air. Okay, so this is the questions here. So what is the meaning of this question at first? So this is a two charge body. Consider this one is the first charge body. Consider this one is Q1, and what is the value of Q1? That is Q1 equals to 2 into 10 to the power minus 7 coulomb. Okay. Another charge body, that is Q2. Its value is 3 into 10 to the power minus 7 coulomb. So these two charge body are separated some distance. Okay. So just check it out. Here it is 2 into 10 to the power minus 7. So this is the positive charge because plus sign is present. And same thing, this is a 3 into 10 to the power minus 7. That is also, it is also a positive charge. Okay. So both these two positive charge. So first questions arises in your mind, both these two positive charge. So in my last video we discussed about that, both these two positive. That means what is the nature of the force? Tell me. That is obviously this is repulsive in nature. Okay. Now consider this is separated by some distance. This distance is D. Okay. So D equals to 30 centimeter. Clear? So now this is 30 centimeter. So Q1 it is just given over there, that is equals to 2 into 10 to the power minus 7 coulomb, and Q2 that is equals to 3 into 10 to the power minus 7 coulomb. Okay. And what is the D? D equals to distance, that is equals to 30 centimeter. Okay, so 30 centimeter converted into the meter. So 30 centimeter obviously that is equals to 0.3 meter. Clear? So now we just want to solve the problem. So we know that according to the Coulomb's law of F equals to 1 by 4 pi epsilon 0. Obviously, we follow the SI systems. SI system, because coulombs is present in SI system and this is converted into the SI unit, that is 0.3 meter. So we just write over there, that is F equals to 1 by 4 pi epsilon 0 into Q1 Q2 by d square. This one, okay. So value of 1 by 4 pi epsilon 0, we discuss about that. That is equals to 9 into 10 to the power 9. Okay. So this one is 9 into 10 to the power 9. Now Q1 and Q2, we just want to find out the Q1 and Q2 value. So in Q1, that means 2 into 10 to the power minus 7, and Q2, this one is 3 into 10 to the power, so 3 into 10 to the power minus 7, okay, divided by d square. What is d? That is 0.3. So 0.3 square. Okay. Now what we can solve it? Maximum student just solve it up to this part. Okay, and then he or she just want to say that don't waste my time. We just can't solve this. We can write over there. Okay, so don't do that. So how to solve? So this one is 9. Okay, so 9 into 10 to the power 9. Okay, so just we write over there. That is write 9 into 2 into 3. Okay, into 10 to the power 9. Into 10 to the power minus 7, that is 10 to the power minus 14. Okay, that is 0.3. This one 0.3 means, that is, it may be written in the form 0.3 square. That means 9 into 10 to the power minus 2. Am I right? Because 0.3, that means 3 into 10 to the power minus 1. Square of it, that means 0.3, that is 3 into 3, 9. 9 into 10 to the power minus 2. Okay, I think it is clear. So now 9 cancel out. Okay, so that is 2 into 3. What is the value? That is equals to 6. Okay, now this one minus 2. So minus 2. Now it may be written in the form, that is 10 to the power 9. This one is moved. So 9 plus 2, that is 11 minus 14. Okay, so that is equals to 6 into 10 to the power minus 3. This one, the force. Okay, so what is the unit of the force? Obviously in Newton. So we just write 6 into 10 to the power minus 3 Newton. This is the value of this. Okay, what is the force? That is what is the nature of the force? That is repulsive nature. So we just say that force F equals to 6 into 10 to the power minus 3 Newton. This is repulsive. Okay, up to this clear? So we move to the next question. Okay, now we come back again. The second problem, that is 1.2. Okay, the electrostatic force on a small sphere of charge 0.4 microcoulomb due to another small sphere of charge minus 0.8 microcoulomb in air is 0.2 Newton. Okay, what is the distance between the two spheres and what is the force on the second sphere due to the first? Okay, this is the questions. Two questions are present, A and B. So first one, we just consider about that, the two small spheres. The first one, this is the solutions. So this one is the first sphere and this one is the second sphere. This one 1 and this one is the second sphere, Q. So first sphere, what is the charge on the first sphere? That is 0.4 microcoulomb. Okay, and what is the charge on the second sphere? That is 0.8 microcoulomb. This one is negative and this one is positive. Okay, so these two charged sphere are separated by some distance. We consider the distance is d. Okay, at first imagine it. And what is the force between? This is positive, this is negative. So positive and negative force, that means obviously attractive in nature. So this force is represented by 0.2 Newton. That is the force. So this force F equals to 0.2 Newton. So we just write over there. That is the first. If I consider this one is Q1 and this one is Q2. Okay. So Q1 equals to 0.4 microcoulomb. Okay. And next one, that is Q2 equals to 0.8 microcoulomb. We ignore the negative sign because negative sign implies that the force is attractive in nature. Two are opposite charges. That's why the force is attractive in nature. That's why we write the negative sign. We ignore it. So here it is. This one microcoulomb, this one microcoulomb. So we want to solve the problem either CGS method or SI. Generally, we want to solve here in SI system. So we just convert the microcoulomb into the coulomb. So when we convert the microcoulomb into the coulomb, so what is the value? That is 0.4 multiplied with 10 to the power minus 6. Okay. So this one represents 10 to the power minus 6 coulomb. Similarly, 0.8, this one also multiplied with the 10 to the power minus 6 coulomb. Okay. Here the force, next one, that is the force. Force represents 0.2 Newton. Okay. This is in SI system, so no need to change. So another one, we consider the distance. The distance that is equals to d. Here we consider this is. So at first we write the Coulomb's law. So again we write that is F equals to 1 by 4 pi epsilon 0 or epsilon naught Q1 Q2 by d square. Okay. So d square equals to 1 by 4 pi epsilon naught Q1 Q2 by F. Just simple. So 1 by 4 pi epsilon naught, what is the value? 9 into 10 to the power 9. Okay. Just you remember, in this way when you solve, that is all the numericals is very much easy. So that is 9 into 10 to the power 9. This one. Okay. What is the value of Q1? Q1, this one is 0.4 into 10 to the power minus 6. So we just write over there that is 0.4 into 10 to the power minus 6. Okay. Now Q2. Q2 is value that is 0.8 into 10 to the power minus 6 coulomb. Okay. So divided by F. What is the value of F? That is equals to 0.2 Newton. So divided by 0.2. Now we just want to solve it. So 0.2 and 0.8. This one cancel out. So 4. So 9 into 4. What is the value? That is 36. In this way you solve. When you cancel out in this method and in this way you can add it and subtract it. So by this you can solve any problem. Okay. So 9 into 4, that is 36. Okay. Here it is 4. 0.4. Just think about 0.4. We just convert it into, that is 4 into 10 to the power minus 7. Am I right in this thing? So that is 4 into 10 to the power minus 7 into 10 to the power 9 into 10 to the power minus 6. Clear? So 36 into 4, just we want to solve it. So we write here. This one, all this d square. So we just write. So d square equals to 36 into 4. That is 144. Okay. So minus 7 plus 9 minus 6. So 7 minus 6. What is the value? Minus 7 minus 6? 13. Okay. So 10 to the power 9 minus 13. Okay. So this one. So it may be written in the form that is 144 into 10 to the power minus 4. Is it clear? So 144 into 10 to the power minus 4. What is the value? This one is d square. Okay. So this one is d square. So what is the value of d? So d equals to obviously root over of this. That is 144 into 10 to the power minus 2. Okay. 144 root, that is equals to 12. And this one is 10 to the power minus 2. It may be written in the forms. That is equals to obviously. So this one is 10 to the power minus 4. And due to the square root, that is 10 to the power minus 2. Okay. So that is 12 into 10 to the power minus 2. So this is the value of the distance. Okay. So d, that is separated by the body, that is equals to 12 into 10 to the power minus 4, that is equals to, obviously it may be written in the forms. Okay. So 12 into 10 to the power minus 2. And the attraction force between them, it may be written in the forms, that is, so 10 to the power minus 2, it may be written in the form, that is 0.12 meter. Okay. So what is the next question? What is the force? Now up to this clear? Any doubt to anyone? Okay. So we just move to the next one, that is what is the force on the second sphere. So take a screenshot of it. Take a screenshot of it. Then we move to the next one. Okay. Now we move to the next one. Okay. So now the second problem, this one. What is the force on the second sphere due to the first? Okay. So here the force, same thing, that is the force on the first sphere. This is the first one, that is Q1, this one Q2, two spheres separated by this one 1 and this one is 2. Okay, these two spheres, what is the force between them? The first one give the force on the second, that is F equals to 0.2 Newton. Okay, same thing, the second sphere also give the same force. So the second sphere also give the same force. This value is also 0.2 Newton. Okay, only difference is that force is both are positive, another one is positive, another one is negative. So this force is repulsive in nature only. Okay, this force is same. The first sphere give the same force, that is the force is 0.2 Newton on the second body or second sphere. Same thing, second sphere give the force on the first one, that is also 0.2 Newton. Okay, but the force is repulsive in nature in both the cases. Okay, you just remember only these things. Okay, now we move to the next questions, and after that we can solve the other problem also. Okay. Okay. So we move back to the third question, that is 1.3. Here, check that the ratio of k square by g me into mp is dimensionless. Look up a table of physical constant and determine the value of this ratio. What does the ratio signify? This is the question. Okay. So what we can solve? So there are two questions are accommodated over there. So first one we have to find out, that is k square by g me into mp. K. So what is k? Obviously, according to the electrostatic force, we know that k is a constant. Okay, and the value is 1 by 4 pi epsilon 0. Same thing, that is g into me into mp. G, that is the gravitational constant, gravitational universal constant that you know from the chapter of gravitations from class 11. So at first we find out the dimension of k and g also. So here from the electrostatics, force of electrostatics, we know that the electrostatic force, okay. So what is the force? That is the Coulomb's force, obviously. So 1 by 4 pi epsilon 0 or epsilon naught q1 q2 by d square, this one. Okay, so this 1 by 4 pi epsilon naught, it is equals to k. So it may be written in the form that is k into q1 q2 by d square. Okay, so what is the value of k? So that is k equals to q1 q2 by f into d square. Am I right? F equals to k into q1 q2 by d square. This is the electrostatic force. So what is the value of k? That is when you write in this manner, that is F equals to k into q1 q2 by d square. Okay, so we want to find out the k, value of k. So once again, it may be written in the form that like that. So k equals to F into d square by q1 into q2. Okay, now we want to find out the unit of it. What is the unit of force? That is Newton. So this one is Newton, and d, that is the distance, so it is meter square, and q1 q2 that is the charge body, so that means coulomb into coulomb, so coulomb square. So it may be written in the forms, that is Newton meter square coulomb to the power minus 2. Am I right? So this one, the units of SI units of k. Same thing, we just want to find out the units of g. So what is g? That is the gravitational universal constant. So gravitational force, we just come back to the again gravitational force. So gravitational force F equals to g into m1 into m2 by d square. Okay, so that means g equals to F into d square by m1 into m2 this way. Okay, so if again it is written in the form that is Newton, it is meter square, and m1 into m2 that is equals to, it is right in the SI system. Okay, so value in this case that is equals to kg into kg, that is kg square. So Newton meter square into kg to the power minus 2. So this one. Okay, so we just want to find out this ratio dimension, or first find out the units of this. Okay, so k is square by me into mp. Now a question arises in your minds. Sir, here the question is check the ratio k square g me into mp is dimensionless. We have to solve, it is dimensionless. But you just want to find out the SI units. Why this is? Because any units, okay, this is the quantity F force, here G and K, we just find out the unit of it. If I find out the ratio of the units and its value becomes 0, okay, so unit is 0, then the dimension is also 0 in the same way. Okay, so that's why we just find out the units. When we find out the units, find out the ratio of this. If it is 0, then dimension is also 0. Okay, so we just write here, there is force K equals to K SI units, that is Newton meter square coulomb to the power minus 2, this one. It is multiplied with the E square. What is E? That is the charge obviously. So this one is coulomb square, that is C2. Okay. Now G, next one, that is equals to Newton meter square kg to the power minus 2. Okay. It is multiplied with the me into mp. What is me? The mass of the electrons. And what is mp? The mass of the proton. So both are mass. So we just write in the form of, obviously in SI system, that is equals to kg into kg, obviously kg square. Okay. So now Newton meter square, this one, C minus 2 plus 2. So C power of 0. Okay. So this may be written in the form C minus 2 plus 2. So this is 0. So again, this is Newton meter square kg minus 2 plus 2. This one is also 0. And here Newton cancel out, meter square cancel out. So what is the unit in this case? That is equals to 0. So 0 means this is unitless, that is no unit is present. So this one, the ratio is unitless. When the ratio is unitless, therefore there is no dimension. So the dimension, there is no dimension. Or it is dimensionless quantity. Dimensionless value. Okay. So in this way, we just find out the SI unit of it. Okay. In both this case, then find out the ratio. When you find out the value of ratio is 0. So ratio is 0. That is unitless. It is unitless. It is unitless means there is no dimension. Okay, that means it is dimensionless. Now we move to the next questions. Okay, so the next one, the question 1.3 also. So this we just find out the diet is dimensionless. Now the next one, there is a physical constants and determine the value of the ratio. We just want to find out the value of this ratio. Which ratio? That is k square g into me into mp. And we also find out the what does the ratio significance in this case. So here it is, that is k square by g into me into mp. We just discussed this is me. Me means mass of the electrons. Okay. Same thing. This one is mp, mass of the protons. Here k equals to 9 into 10 to the power 9. We already discussed what is the unit. We just calculated over there. That is Newton meter square coulomb to the power minus 2. G, that is a universal gravitational constant. Its value is 6.67 10 to the power minus 11 Newton meter square kg to the power minus 2. E, that is 1.6 10 to the power minus 19 kg. Me, that is 9.1 10 to the power minus 31 kg. MP, that is equals to 1.66 10 to the minus 27 kg. You just remember the following value, okay? So when you just remember putting all this value, you can easily solve this. Now we just want to show you that is what way you can calculate this, okay? You just remember this value. Just take a screenshot of this, okay, and you remember. So first one, k into k square. What is k? That is 9 into 10 to the power 9. Okay. So divide into e square. What is the value of e? That is 1.6. That is 1.6 into 10 to the power minus 19 square. This one. Okay. Now g into me into np. G equals to 6.67 into 10 to the power minus 11 into me. What is me? That is mass of the electrons. This one is 9.1. So we just write here 9.1 into 10 to the power minus 31. Okay. Into, that is MP. MP equals to 1.66. This one. So 1.66 into 10 to the power minus 27. So putting all this value, I think it is clear. So putting all this value, we just want to calculate this. So here it is 9 into 10 to the power 9. Here 1.6 square. 1.6 square, that means it 1.6 into 1.6, that is 2.56 into 10 to the power minus 19. 10 to the power minus 19 plus 10 to the power minus 19, that is 10 to the power minus 38 in this case. Okay, so that is 10 to the power minus 38. Okay, here it is 6.67 into 9.1 into 1.66 into, it is approximately the value, just second bracket out, that is this is minus 11 minus 31 minus 27. Okay, adding all this part, we just get the value. So this one is minus 69. Okay, so 9 into 2.56, 9 into 2.56, calculate this value. So it may be near about 23.04. Okay, so 23.04, 10 to the power plus 9, 10 to the power minus 38. Okay, so subtract this value. So into 10 to the power 9 into 10 to the power minus 38. Clear? Now 6.67, 9.1, 1.666. When we multiply this part, so this value is almost 100.76 into 10 to the power minus 69. Okay? So 23.04, this is taken out as a 100. So when it is 100, so it is obviously okay. So we just solve 23.04, 10 to the power 9, 10 to the power minus 38, and this one is 10 to the power minus 69. So we just write here 10 to the power 9 plus 69 minus 38 divided by 100.76. It can be taken as 100, okay, for calculations. So 23.04 divided by 100. When you divide by 100, so it may be approximately 0.23. We call it 0.23. Then this one is 9 plus 69. This is 78. So 78 minus 38. Okay. So it may be written in the form that is 0.23 into 10 to the power 40. Okay. So this one. So it may be also written in the form that is 2.3 into 10 to the power 39. Okay. So this is the ratio, the value of the ratio 2.3 into 10 to the power 39. Okay. So in this way we can solve it, we can calculate it. It is very easy. Okay. When you solve it in this method, so you can calculate very much easily. Now the next one. What does the ratio signify? Here ratio, what is the ratio? That is k square g into me into mp. This value is 2.3 10 to the power 39. Okay. Now this from this ratio 2.3 10 to the power 39. This is obviously unitless quantity, already we solved. So here the value is maximum, too much larger, because 10 to the power 39. Consider about it. Okay. So 2.3 into 10 to the power 39. So it is much larger, and it is represent the ratio of the electrostatic force and the gravitational force in this sense. Okay, so electrostatic force and the gravitational force, this is the ratio. This value is 2.3 into 10 to the power 39, and it is quite larger. So we just write in this case, that is electrostatic force is much greater than that of the gravitational force. Okay, so what we write at first? The electrostatic force is much greater than that of the gravitational force. Okay, because the ratio is maximum, that's why we can say that the electrostatic force is much greater than that of the gravitational force. Okay, so we move to the next problem. So we come back again. So this problem 1.6. So 4-point charges, QA 2 microcoulomb, QB minus 5 microcoulomb, QC 2 microcoulomb, and QD minus 5 microcoulomb are located at the corner of a square ABCD of side 10 centimeter. Just check it out. This is the square ABCD. Okay, the 4 charges. First one QA, there is 2 microcoulomb. It is placed at the positions A, at the corner A. QB, that is minus 5 microcoulomb. It is placed at the positions B. QC 2 microcoulomb at the corner C, and QD also, that is equals to minus 5 microcoulomb. It is at the corner of D. So here the sides of A and B, B and C, this is square, so all are 10 centimeter. Okay, so now are located at the center. So what is the force on a charge of 1 microcoulomb placed at the center of the square? Here another charge is placed 1 microcoulomb placed at the center point O. Okay, just check it out. This one is positive, 1 microcoulomb, this one is positive. So this is 2 microcoulomb. So obviously both are positive. So this force is repulsive in nature. So it is directly along this. Okay, so in this way we just localize these forces. Clear? So one force is acting along this. This is maybe repulsive in nature or attractive. Same thing, FB acting along this, FC acting along this, and FD acting along this. The one charge 1 microcoulomb is placed at the center. Okay, here just check it out. This is FA, the force between 1 coulomb. Here charge QA and QC both are same. That means QA equals to QC, that is equals to 2 microcoulomb. Both the value, that is the value of charge QA and QC at the two opposite corner of a square. This is equals to 2 microcoulomb. Same thing, that is QD and QB both are minus 5 microcoulomb. Same thing, that is QB equals to QD, that is equals to minus 5 microcoulomb. Both are same. So that means, just take it out, that is fast at the center, it is 1 microcoulomb. So 1 microcoulomb and this is 2 microcoulomb. The force acting between them, and 1 microcoulomb, this is also 2 microcoulomb. The force acting between them, both are same. So in this case, for the first one, we just write, for the first case, FA and FB both are same because QA equals to QC. Okay, what is the force FA and FB? FA is the force due to the charge 1 coulomb placed at the center. Same way, we just write the force FB and FD both are same because QB equals to QD. Okay, what is the force FA, FB, FB and FD? FA, FB, FC and FD. So this one FC. Okay, So both are forced due to the charge body, 1 coulomb at the center. So in this way you can solve. Today we discuss up to 1.6. In my next video I will discuss the later on, okay, from 1.7 to the next one. So definitely watch my video and positively solve this problem at your home and try to solve in this following method. When you solve in this way and number of times when you solve it, you can solve the other problem also. Okay, so try to solve all this problem, all these calculations in this way. Okay, thank you very much, and we come back soon with a new video. Thank you again.